Binary logistic regression with one binary predictor or one ordinal predictor in JAMOVI. Binary logistic regression with binary predictor in JAMOVI. Binary logistic regression is a statistical techniques or method or test that can be used to find out whether there is an association or a relationship between two variables. One of the variable is called outcome, or it is called response or dependent variable, and the second variable is the predictor, or it can be called the explanatory or the exposure or the independent variable. The aim of this logistic regression test, the binary logistic regression test, is to find out whether the predictor can predict the outcome and whether the variation in the outcome can be explained by the predictor. To use this test, the outcome has to be binary. A binary variable is a variable that consists of only two levels, such as yes or no, have diabetes, no diabetes, have heart diseases, no heart diseases. So the outcome has to be binary to perform binary logistic regression. However, the predictor can be continuous, can be binary, can be multinomial, or it can be ordinal variable. A binary predictor, again, is a predictor or a variable that have two levels in it, such as gender, male or females. Here in JAMOVI data sheet, I had inserted 100 cases, and there are two variables. The first variable is the gender and have two levels in it, males and females. And a second variable, which is the heart diseases, whether you have heart diseases or no heart diseases. So the sex here variable is a binary variable, and the heart disease is also a binary variable. But the heart diseases here is an outcome, as we want to find out what is the chance of developing heart diseases. So here we have one outcome, which is binary, and a predictor, which is again binary, as it has two levels in it. So these two variables are both binary. To find out whether there is association between gender and possibility of developing heart diseases, or whether one of the sex have higher probability or higher chances or higher likelihood of developing heart diseases than the other, then the best test to go for is binary logistic regression. Before we perform and do the test, let's look at some descriptive statistics by clicking on exploration, select on descriptive, and then let's drag the sex to the box of variables and the heart diseases into the box of variables, and then tick on the frequency table here, and from statistics we'll remove the median and the mean, as both variable are categorical, i.e. binary, has two levels in it. We don't need the standard deviation, no need for minimum and maximum. So looking at the output from the descriptive statistics here, the first table shows that there are 100 cases. There is no missing cases for any variable. This is a good sign. For the frequencies, it shows that there are more females than males. 52% are females and 48% are males. For heart diseases, there are more heart diseases cases than non-heart diseases. 56% of cases have heart diseases and 44% don't have heart diseases. To perform binary logistic regression, click on regression here and then select two outcomes binomial for regression. If this function is not available here in the menu, click on the module here and then add that through the JAMOVI library. So back again to regression, click on outcome for binomial regression. A new window is generated. Here we can see that we have two variables. We'll move the outcome, which is the dependent variable, into the dependent variable, and 6 we will move it into the factor here. Since it is binary, let's select some options from the list here. For model builder, nothing to choose from. For the reference levels, since we have two variables, both variables are binary. For the heart diseases, the no heart diseases will be the reference category to compare to, and for the 6 variable, the females will be set as a reference category, and the males will be compared to females. For the assumption checks, no, we'll not look at it at this stage. For model fit, take on the Cox Snell R Square and the other R Square. For the model coefficient, take on the odds ratio and the 95% confidence interval. Looking at the output from the JAMOVI section here, there are multiple tables. The first table is the model fit measures. Looking at the R square value here, which is 0.735, this R square means that 73.5% of the variation in the outcome, which is the heart diseases, can be explained by the predictor, which is the sex or the gender of the individual. This is a high value. Moving to the second table, which is the model coefficient for, again here, heart diseases. So we are here looking at heart diseases, and that's what we will interpret from this table. For the predictor section, males to females, again, the females will be the reference group here, so male will be compared to females. The estimate, which is the coefficient, is given here, the standard error, the z-score, the p-value, the odds ratio, and the 95% confidence interval for the odds ratio. So here we have two levels of determining whether there is significance or not. P-value, if it is less than 0.05, then it is significant. And the 95% confidence interval, in which the odds ratio should fit between the lower and the upper limit for that confidence interval. From this table, it is well shown that there is a significant association between the gender and probability or possibility or likelihood of developing heart diseases, as the p-value is significant and the odds ratio fell between the 95% confidence interval. So essentially, yes, there is this test will answer the question, yes, there is association between individual gender and the probability of getting heart diseases or the odds of hitting heart diseases. The way to interpret this table is that males have a higher probability or likelihood of getting heart diseases than females, and this probability is significant. In another way, males are more likely to develop heart diseases than females, with an odds ratio of 224.5. So from this table, males having a higher likelihood or probability of developing heart diseases. So this is the way to perform binary logistic regression in JAMOVI with a predictor that is binary, that is made up of or consists of two categories. Binary logistic regression with ordinal predictor in JAMOVI. Here in JAMOVI data sheet, I had inserted 200 cases, and there are two variables. The first one is the age category, the second one is diabetes. So the diabetes is a binary variable because it has only two levels in it, whether you have diabetes or no diabetes. Age, though age is continuous, but here it is classes or categories. Category from 16 years old to 24, and then the second category is from 25 to 45. The third one is from 46 to 70, and the fourth one is greater than 70 years old. So there are four categories here, youngest one to the oldest one, though it is age, but it is in category and there is order in it, youngest, older. So this is a ordinal variable. It is categorical, but it is ordinal, more precisely ordinal, as it has order in it. So to find out whether there is association or relationship between the age category and the diabetes, and whether this predictor, which is the age category, can predict possibility of getting diabetes, or the outcome, which is diabetes, variation in it, can be explained by the age categories, then binary logistic regression can be used, as the outcome here, which is diabetes, is binary and the predictor is ordinal. Before we proceed to the regression, let's look at some descriptive statistics. Click on exploration and then select descriptive, then drag the age category into the variables, the diabetes into the variables, tick on the frequency tables. Let's get rid of, since both of them are categories, we don't need the mean and the median. We remove the standard deviation, we keep the minimum and the maximum. From the output for the descriptive analysis, there are 200 cases. So both variable, there are 200 cases and no missing cases as shown here. The age category is assigned values 0, 1, 2, 3. The 0 assigned for the age category from 16 to 24. The value 1 assigned for 25 to 45, and value 2 assigned for 46 to 70, and 3 for anything greater than 70 years old. The second table shows the frequencies in each category. So as we have 4 categories here, there are 50 individual or cases in each category. For the binary outcome, which is a diabetes, there are 81 cases of those who have diabetes and 119 without diabetes. So those who do not have diabetes have a higher proportion. To do binary logistic regression, click on regression, scroll down to the 2 outcome binomial. Since this these data fit perfectly to the binary logistic regression. In this window, diabetes is our outcome, so we'll move it to the dependent variable. And since the age categories is factors, we'll keep it into the factors. We could move it to covariate, but we'll keep it here into the factors, and the age category is best fit here. Let's select some of the options here. We'll click on the reference levels. Since we have here 2 variables, both of them have categories in it. The diabetes have either you have diabetes or yes or no. No will be used as a reference category to compare to. Age category, which is from 16 to 24 years old, will be used as a reference category to compare to. Moving to the, I'm going to skip the assumption checks. Moving to the model fit, tick on the Cox and Snell R Square and the other R squares. For model coefficient, I'm going to tick on the odds ratio and the 95% confidence interval. For estimated margin, no selection. For prediction, no selection at this stage. Looking at the output here, we have two important tables. The first table is for model fit measures. Looking at the R square here, it shows that a value of 0.255. This value means that 25.5% of the variation in the outcome, which is diabetes, can be explained by the predictor, which is the age categories. Moving to the second table, which is the model coefficient for diabetes, we used those who with no diabetes group as a reference group. And for a predictor, which is the age categories, all the three are compared to the reference category, which is 16 to 24. So this is the reference category here. In the table, we're going to ignore the intercept, and looking at the footnote here, it says that the odds of diabetes for yes and no. Values here is estimate for the coefficient, the standard error, the z-score, the p-value, the odds ratio, and the 95% confidence interval. So there are two levels here for checking significance. P-value, any p-value less than 0.05 will be considered as significant, and 95% confidence interval, when the odds ratio fit between the upper and lower limit, then it is significant. So here from this output, we can see that there is a significant association between diabetes and the predictor, and even with each categories of the predictor. So there is association. The outcome, variation in the outcome in diabetes can be explained by the age category. So age is a factor that can explain whether you will have a chance, probability, likelihood to get diabetes. The way to interpret this table is that looking at the first category, for those individuals who are in the age range of 25 to 45 years old, have an increased 3.1 odds of having or developing diabetes compared to the younger generation, which is, or younger individual, 16 to 24. So older individuals have a higher chances or are more likely to develop diabetes than younger one. For the second category, which is from 46 to 70 years old, those individuals in that category have an increased 7.3 odds of developing diabetes compared to the younger group. So with increased age category, the odds increase or increases. So that means the elder people have a higher likely chance of developing diabetes. Looking at the final category here, those who greater than 70 have the highest likely or chances of developing diabetes compared to the younger group from 16 to 24. And all these findings are significant. So this is the way to perform binary logistic regression with an ordinal predictor in JAMOVI. If you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, JAMOVI, R Statistic or Statistics, GraphPad, Prism, GPower, Python, and RevMan. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, JAMOVI, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.